Hello learners, I am Dr. R.B. Malati, Assistant Professor at Chhattisgarh Swami Vivekananda Technical University, Bhilai. I welcome you all again to the course Fundamentals of Building Construction. In this lecture on stairs and staircases, terminology and classification, we will look into the definitions of stairs, technical terms involved in it, the requirement of a good stairs and the classification of stairs. Let us look at few notable staircases from around the world just to set the stage for the subject. I have chosen 3 iconic staircases that captured the imagination of engineers and admirers alike. Let us begin with the Vessel, a striking modern structure located in Hudson Yards, New York City. Comprising 154 interconnecting flights of stairs, this is a giant beehive. From the top, you get awesome views of the busy city below. Next, if you go back to the 17th century in London, another marvel of early engineering and architectural beauty, the Tulip Stairs at Queen's House in Greenwich, London. Built as a part of Queen's House, these spiral stairs are renowned as the first geometric self-supporting spiral stairs in the country. Let us take our journey to Rajasthan, India, where we can discover the Chand Bauri stepwell, which is over 1,000 years old. It is an amazing structure with symmetrical stairs that go deep into the ground to reach a water reservoir. These stairs are more than just a way to get from one place to another. They are pieces of art and history that show how creative and smart people have been throughout time. With these examples in mind, let us start learning about stairs and staircases. First, let us get some basic definitions straight. A stair is simply a set of steps that lead from one floor to another. The space that the stair occupies is called the stairway. The room or enclosure where the stair is located is known as a staircase. Let me repeat that. A stair is a set of steps leading from one floor to another. The space occupied by the stair is known as the stairway. The room where the stair is located is called the staircase. Now, when it comes to the location of stairs in building, there are some important points to consider. In domestic buildings, stairs should be centrally located. This makes it easy for everyone to access all the rooms. In public building, it is a good idea to have the stairs near the entrance for convenience. Whereas in large buildings, you might need multiple staircases to ensure people can move around easily and safely. And these stairs can be made from various materials. You have options like timber, bricks, stone, steel and reinforcement cement concrete. Each material has its advantages and is chosen based on the building's need and design. So, to sum up between, the central location of stairs in domestic building is for easy access. In public buildings, they should be near the entrance, and in large buildings, multiple staircases may be necessary. And remember, stairs can be constructed using materials like timber, bricks, stone, steel and RCC. Let us continue our discussion on staircases by focusing on the fire protection and strength. One major key point here is that staircases should be enclosed with fire-resistant walls, floors, ceilings and doors. Why? Because this helps to keep escape routes safe during a fire. For instance, in May 2022, a fire at electronics factory in Mudkan, New Delhi led to 27 deaths. The reason is the factory lacked proper fire safety measures like clear emergency exit. Similarly, fires at a gaming zone in Rajkot, Gujarat and a children's hospital in Delhi claimed over 40 lives. These incidents show how much important it is to use non-combustible materials and ensure walls around the staircases have a strong fire-resistant rating as per Indian's National Building Code, shortly known as NBC. today is an era of modern buildings. If you have noticed in modern high-rise buildings, staircases are often enclosed in concrete with fire-resistant doors. This design helps stop fire from spreading between floors, making the evacuation safer. Now, let us talk about the strength of the staircases. Strength is another important aspect. Stairs must be designed to carry specific loads similar to those used for floor design. For example, in commercial buildings, staircases are designed to support the weight of multiple people simultaneously during peak hours. And besides stairs, there are other means of vertical transportation between floors which you have noticed often. Can you please say some? Yes, lifts or elevators, ramps, ladders and escalators. Lifts are efficient for tall buildings and are essential for people with mobility issues, and ramps are useful for wheelchair access. Ladders are typically used in emergency situations or for access for small, infrequently accessed areas. Escalators are common in building malls and airports for the continuous movement of people. To sum up again, ensuring fire protection in staircases with non-combustible materials and strong fire resistant rating is vital for safety. Additionally, designing staircases to handle specific loads ensures their strength and reliability. Reliability meaning the probability that a product, system or service will perform its intended function adequately for a specified period of time or will operate in a defined environment without failure. Yes, in simple terms, it is the product should serve for the purpose it is made for. Let us now explain the technical terms involved in stairs. Kindly look into the figure and follow the lecture simultaneously for easy understanding. First comes a step. A step lets you move up or down. Each step has two parts, the tread and the riser. Think about the steps in your home. Every time you go up to the bed or down to the kitchen, you are using steps, isn't it? Next comes the tread. This is a flat horizontal part of the step where you place your foot. When you walk up your stairs at home, the part you step on is the tread. It is like the stepping stones in a garden path, flat and stable. Then the riser. This is a vertical part that supports the tread above it. If you look at your home stairs, the upright part you see between each tread is the riser. Imagine each riser as a spine that holds each steps in place. Then comes the flight. A flight is a continuous series of steps without any landing in between. Think about the stairs in a multi-story building. The section that goes straight from one floor to the next without stopping is a flight. Landing. This is a flat area at the top or bottom of the flight of stairs or between flights. Picture a shopping mall staircase. The landing is where you can pause, rest or change direction. Rise. This is a vertical distance between two successive treads. When you step from one tread to the next, the height you lift your foot is a rise. It is like climbing up a ladder and each rung is a rise. Remember here, rise should not be confused with riser. That is vertical part and this is vertical length. Going. This is a horizontal distance between two successive risers. Imagine measuring the distance your foot moves forward from one step to the next on your stairs at home. That is a going. It is like the stride length in your walk. Nosing. The nosing is a part of the thread that sticks out past the riser. Next time you use stairs, notice the slight overhang on each step. That is a nosing. It is often rounded for safety and looks nice too. Squasher. This is a decorative molding under the nosing that adds strength. Look closely at a nicely finished stairs and you might see a decorative strip under each thread. It is like the trim around a window adding a finishing touch. Soffit. This is the underside of a stair. If you look up while standing under a staircase, the surface you see above you is the soffit, simply the underside of a stair. Line of nosing. This is an imaginary line that runs along the edges of the nosing. It is used to construct handrails, ensuring they follow the correct path. Imagine drawing a line connecting all the edges of each step's nosing. That is a line of nosing. Pitch or slope. This is the angle the line of nosing makes with the horizontal. Think about the slope of the stairs at your own college. If it is around 35 degrees, it is designed for comfort and efficiency. It is like the slope of a hill, making the climb easier or harder. Strings or stringers. These are the sloping supports that hold the steps. When you look at the side of a staircase, the boards running along the stairs length are the stringers. Think of them as the backbone of the staircase. Newel post. This is a vertical post at the ends of the flight that connects the strings and the handrails. In a traditional wooden staircase, the large post at the top or bottom of the stair is the newel post. It is like the anchor point for the staircase. Next comes the baluster. A baluster is a vertical member that supports a handrail. Think of a vertical post between the steps and the handrail on any decorative staircase. They are like the pickets in a fence, providing support and safety. Balustrade. These consist of rows of balusters topped by a handrail. The railing system along a balcony or staircase is a balustrade, providing safety and support. It is like the guardrail on a bridge. Handrail. This is a rounded or molded part you hold on as you go up or down the stairs. It follows the contour of the nosing and is mounted on top of the balusters. It is like the handlebar on a bicycle, providing stability and control. Headroom. This is a clear vertical distance between the thread and the overhead structure. Make sure to notice the space above your head when you climb stairs. Sufficient headroom ensures no one bumps their head. It is like the clearance you need when driving under a bridge. Run. This is the total horizontal length of the stairs, including the landings. Imagine measuring the entire length of a staircase from start to end horizontally. That is the run. It is like measuring the length of a hallway. Finally, header. This is a horizontal structural member that supports stair stringers or landings. It helps to distribute the load and keep the staircase stable. It is like the beam that supports the roof of a house. True, many terms, and it is done. Actually, these terms play an important role in the design and functionality of staircases, and understanding these principles not only aids in appreciating good design but also ensures safety and efficiency in use. Sure, let's now understand the requirement for designing stairs. There are 6 main requirements. They are location, width of stair, length of flight, pitch of stair, headroom consideration and step dimension. First, location. Stairs should be easy to find and use. They should be well lit and ventilated directly from outside. Think about a staircase in a house that's near a window. It feels safer and more inviting, right? That's how the choice where to place a stair has to be. Width of the stair. Stairs need to be wide enough so people can use them comfortably without bumping into each other. In a house, a 90 centimeter wide staircase is usually fine. But in places like shopping malls or public buildings, you might need stairs that are 1.5 to 1.8 meters wide to handle more people. Length of stairs. No one likes climbing too many stairs at once. Ideally, a flight of stairs should be between 3 to 12 steps. Think about how you feel when you climb a short set of stairs versus a really long one. It is easier and quicker with fewer steps. Yes, the next, the pitch of stair. The slope of stairs should match how people naturally move. If you make stairs too steep, it is harder to climb. So when measured in centimeter units, a comfortable slope is achieved when twice rise plus going is equal to 60 approximately. I'll repeat, twice rise plus going is equal to 60 approx. Thus, pitch should however be limited to 30 degree to 45 degree. Headroom. The clear distance between the thread and soffit of flight immediately above it should not be less than 2.1 to 2.3 meter, so that even a tall person can use a stair with some luggage on its head. Step dimensions. Steps should be comfortable size. The going, how far you step forward, should be at least 25 centimeter, but 30 centimeter is more comfortable. The rise, how high each step is, should be between 10 centimeter to 15 centimeter, like in hospitals for easier walking. Think about how it feels to walk upstairs with really shallow steps. It is easier on your legs, right? Having understood the requirement of designing stairs, let us move to classification of stairs. Stairs can be classified into two broad heads. First is straight stairs and the second is turning stairs. In the turning stairs, we have quarter turn stairs, half turn stairs, in which we will be looking into dog-legged and open well stairs, then 3/4 turn stairs, bifurcated stairs and continuous stairs. Each of the turning stairs are of three types, that is newel stairs, well or open newel stairs and geometrical stairs. Continuing this, first is straight stairs. Imagine a staircase that goes straight from one floor to another without any turns. Those are straight stairs and are common in smaller houses where there is limited space. They can be a single straight flight or sometimes two flights with a landing in between, like you might see in a simple townhouse or a small apartment. Next is the turning stairs. Turning stairs are more versatile and can fit into different spaces. They come in few types. First is quarter turn stairs. Here let us look into newel quarter turn stairs. These have those sturdy newel posts at the start and end of each flight. They turn either with a smaller landing or with those triangular steps called winders. Imagine walking upstairs that turns sharply at the corner of a building. A newel quarter turn stairs are like that. Great example is the grand staircase in the Palace of Versailles in France. These stairs turn elegantly at right angles with robust newel posts guiding you through the opulent interiors. Next, geometrical quarter turn stairs. These stairs look really sleek because mostly they don't use newel posts at the turns. Instead, the handrails and the sides of the stairs are one continuous piece. You might see these in modern buildings where they want a clean and minimalistic look. Example can be found in the Apple store on 5th Avenue, New York. The glass staircase there is a stunning piece of modern architecture that embodies the clean, seamless look of geometrical quarter turn stairs. Similar as that of the quarter, we also have half turn stairs in which we have further types. First is dog-leg stairs. They are called dog-legged because if you look at them from the side, they resemble a dog's hind leg. These stairs have newel posts and can have either a landing halfway up or those triangular winders. Winders meaning a step that is wider at one end than at the other, as in a spiral staircase, to smoothly change direction. And the other open newel half turn stairs. Yes, they are similar to dog-legged stairs, but with an open space between the flight. This makes them look more open and airy, often seen in fancy hotels or homes. This is the only aspect in which it differs from the dog-legged stair. The additional width is required between the two stairs. The space between the two strings may vary from 15 cm minimum to 100 cm. When the space left is more, a small flight continuing 2 to 3 steps may be introduced at the turn between the two quarter space landing as shown in the figure. Otherwise, for small width well, a half space landing may be provided, also shown in the figure. Second type in the main classification of turning stairs is the geometrical half turn stairs. They are really cool, but they don't need newel posts at all. The handrails and sides of the stairs flow smoothly from top to bottom. They may have a landing halfway up or go straight without any break in between. And the third, again in the main classification, we have 3/4 turn stairs. These stairs change direction 3 times as they go up, making them handy in buildings where there is not much space for stairs, but they need to cover a big vertical distance. Iconic staircase in the Vatican Museum in Vatican City is a good example for this. The museum features a remarkable 3/4 turn stairs that is both functional and visually stunning. Fourth is bifurcated stairs. Imagine a staircase in a big building lobby that splits into 2 narrower flights going left and right. Bifurcated stairs help lots of people move around quickly, like at the entrance of a fancy 5-star hotel. Finally, we have continuous stairs. These stairs don't have any breaks or posts along the way. They are one smooth line from top to bottom. They can be circular, spiral like those emergency stairs in building, or helical with more twisty turns, elegant shape. Circular stairs and spiral stairs shown here is usually made either of RCC or metal and is employed at a location where there are space limitation. These are also used as emergency stairs and are provided at the back side of a building. All the steps are winders, that is, therefore, it is not comfortable at all. A helical stair, a subdivision of continuous stair, looks very fine, but its structural design and construction is really complicated. It is also made of RCC, in which large portion of steel is required to resist bending, shear and torsion. What is bending, shear and torsion here? Even though it is not a part of this discussion, I would like to give a glimpse of it just to enjoy the essence of the subject. Yes, here is a simple explanation. First, bending. Bending occurs when a force is applied perpendicular to the length of the material, causing it to deflect. This happens because one side of the material experiences compression while the other side experiences tension. Imagine a simple scenario where you place a ruler on 2 supports, one at each end, and push down in the middle. The ruler bends because the top surface is in compression and the bottom surface is in tension. That is all about. Next, the shear. Shear refers to a force that causes 2 adjacent parts of the material to slide past each other in opposite direction. Shear stresses is parallel to the surface of the material, unlike bending, which is perpendicular. Think of a stack of paper. If you hold the stack and push the top sheet sideways with your hand, the top sheet slides relative to the sheets below it. This sliding action is a shear force in action. Then the last one, that is torsion. Torsion involves twisting a material around its longitudinal axis. This occurs when a moment or torque is applied, causing the material to experience a rotational force. Consider turning a doorknob. When you twist the doorknob, you are applying a torsional force to the spindle of the knob. The spindle experiences stresses due to this twisting motion. That is torsion. Hope you got an idea. Again, worry not. This is not the part of staircase at all. But when designing a staircase, it is important to understand the different forces that come into play. That's it. Try saying once, what are those important forces? Yes, bending, shear and torsion. Fabulous. So, these are the types of staircases, and each type of stairs is designed to fit different spaces and needs, whether it is a cozy house or a busy public place. And understanding these types helps not only work well but also look great in their surroundings. Let us also have gained some knowledge on the types of steps in the stairway. Steps in a stairway may be of the following types: flyer, bill nose step, rounded end step, split step, commode step, dancing step and winder. As I always say, kindly look into the figure and follow the lecture simultaneously for understanding the difference between each of these. First, a flyer is an ordinary step of uniform width and rectangular shape in plan. Then, a bull nose step, generally provided at the bottom of the flight, projects in front of the newel post. It ends near the newel, forms the quadrant of a circle. A round-ended step. It is similar to a bull nose step except that it has a semicircular end which projects out from the stringer. Again, a split step is also provided at the beginning of a flight with its end near the newel post. Then comes the commode step. It has curved thread and riser. Then dancing or balancing steps. They are winders which do not radiate from a common center. And at the last we have winders, which are tapering steps such as those which radiate from a point usually situated at the center of a newel. I hope you are able to recollect the meaning of winders. Yes, they are the steps that is wide at one end than at the other. So, there you have it. To summarize, what we have learned till now is stairs are sets of steps connecting different floors, with the stairway being the space they occupy and the staircase referring to the entire structure. Key considerations include locating stairs centrally in homes, near entrance in public buildings, and using fire resistant materials to ensure safety. Stairs should be designed to bear specific loads and accommodate comfortable dimensions for users, including adequate width, flight length, pitch and headroom. This lecture also covered some technical terms like thread, riser, flight, landing and other important for understanding the staircase design and functionality. Again, various types of stairs were explored, including the straight one and the turning one, each serving different spatial and functional needs. We also gained some knowledge on the types of steps in the stairway. We concluded that understanding these concepts not only enhances design appreciation, but also ensures safety and efficiency in use. So, in the next class, we will learn the dimension and geometric design of staircase. Thanks for your attention.